Now, before we get started, I want to do our membership spotlight as we do every week. Mark A. Miller Architects and Builders are excited to announce their upcoming net zero and passive house project happening in the Beverly Shores, Indiana region. You can check them out more on their Facebook page and always follow along with their progress on their building performance and how you can understand how to build better. And ultimately, you know, this is who GHI members are. This is what GHI members do, and so can you. Sign up at our website, greenhomeinstitute.org, become a member, learn more on how you can support these efforts and get many benefits as well. All right, well, welcome to using EPA's National Storm Water Calculator. Before we get started, we always want to give a shout out to our sponsors who support our work. In this case, Sun Radon. Sun Radon tracks 5 key indicators: radon, CO2 equivalency, VOC, temperature, pressure, and humidity to help you determine for you and your clients if your space is healthy. One thing I personally really like about it when I use it in my house is that it really tells me right away, kind of color-coded, whether there's an issue going on, and then I can immediately pull open the app and determine potentially what that issue is and what might need to be resolved, if anything. The device has many powerful features: customized colors, daily IAQ, monthly IAQ reports, synchronization with HVAC equipment, secure data, and 4-year device storage and backup. One thing I also like, there is a dew point sensor. So when you put these down in the lowest level to sense radon, it's also going to tell you around the same point if there's a mold risk issue using dew point. One thing I always keep an eye on in a Michigan basement. One thing that's great for either large multifamily housing developers or builders is you can put a bunch of these all over the place and then make informed decisions on what's going on from a portfolio level, whether it's, you know, your buildings across many portfolios, across many units, or you're a builder and you want to make sure your clients' homes are the healthiest. You can, you know, log in, check this, and if there's an issue, follow up with them. Very cool. Also, if you are a home inspector, you can put these devices out there and make sure you get the appropriate data, especially if you're tracking for Green Star. So check them out over at sunradon.org or .com. Also, our thanks to our second tier sponsor, Niagara Conservation. They have some of the lowest flowing toilets on the planet. You can just see here 375% return on investment at this large multifamily development by switching over to Niagara. Down to 0.8 gallons per flush. I've been using this for a decade. They even go down to 0.5 dual flush. I've been using that recently as too. Vacuum assisted technology, you can't go wrong with that. And you might be afraid. That's okay. We're all get a little nervous. So they have a line of toilets that go up to 0.28, so you can still be low flow, still get your green points. But hey, you don't have to worry. I can promise you it's been working for me for a decade. Check them out at Niagara Conservation. All right, using the National EPA's Storm Water Calculator, this course is brought to you by the Green Home Institute. Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team of 3, and today I will be your moderator. My name is Brett Little. I am the education director here at the Green Home Institute. This course is approved for multiple continuing education units, including LEED, AP, homes, and BD+C, which is pretty new, unusual for us. Also very unique for our courses, specifically approved only for the place pillar. Last but not least, under our Certified Green Home Professional designation, as well as AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Now, before I hand it off to our speaker here today, I'm going to go through a couple high-level things, and then we'll dive into the nitty-gritty of the calculator and how you can use it to hopefully meet your green building goals, surpass your green building goals, meet your sustainability objectives, meet city-based requirements or incentives for stormwater mitigation, or just build better, right? That's what we're here to do. So whatever you're doing, We just want to see you build better and help the environment and help your clients. So the first thing you need to know is that there is a prescriptive and performance-based metric for LEED for homes to do this. And so right now, this tool is mostly focused on the performance-based National Pollutant Discharge Elimination System, NPDES, and I think they have their own acronyms in every state. Corinne will tell you more about that. And so what we're looking at is targeting the 95th or 98th percentile, which is a performance-based approach, perhaps using a tool like this to help make that informed design decision to determine if your project is on track to achieving these points within that system. Now, here's a screenshot of a recent project I'm a lead rater on that I've been working on. And so this is the prescriptive-based approach, which again, the tool can also be helpful for as far as we're using it to submit for some documentation for that. And so this is a much more prescriptive approach that your team can take, filling in all this data of what is going on the project, on the site as well. But that's not something that's going to give you a percentile, which is one of the goals of the Stormwater Calculator tool. Now, this course is also approved for BD+C, the commercial, and the commercial is really set up much in the same way as homes, but there's some different ways you get the points depending on if you're traditional commercial rating project or a healthcare. You can see there are some different points handed out here, whether you're hitting the 95th percentile or the 98th percentile. And then if you go to that link and scroll down, you'll see there's some zero lot line and some nature-based approaches that we're not going to be talking about here today as well for the commercial rating system, but set up much in the same way as homes. Again, you're trying to target that 95th or 98th percentile. Now, LEED v4.1, that's the future. That's where we're headed, right? We're all going to that. And someday LEED v5, which I assume will be replicated off of 4.1. So this is 4.1. It's kind of a 2-for-1 because what it is you can go in and you can see the credits for the multifamily, and you can see the credits for the core and shell, the commercial building. And you can see it's whether it's a traditional project or a zero lot line project, they give you a little more wiggle room in 4.1. Honestly, you can go down to the 80th percentile and still score a point, or the 70th percentile if you're on a zero lot line. And then there's some other ways to meet this too if you go into that credit definition. So a little more wiggle room going on in v4.1. And for you who are using homes in Canada and the United States, there are substitution credits for you. So you can substitute this credit if you don't like, right? If you don't like this one, right? Not as much wiggle room. You can now substitute this one in and use the v4.1 approach for housing projects in the US and Canada. So pretty cool. And one thing I just have to warn you all about that we're always learning, and I'm always learning as I'm doing projects, is you have to be very consistent. So whatever your engineers are reporting in these calculator tools and using for documentation to lead for the site measurements, they have to be consistent with anything else that measures the site, previously developed lots, LT compact development, and especially if you're doing the water performance calculator through the EPA. Another shout out to Corinne's colleagues doing another great program there that we've had on before. Again, these all have to be consistent measurements. You cannot deviate. You can't try to tweak the measurements to make the site smaller to help you in one area and make it bigger to help another. They must be consistent or they will be rejected by the lead provider and the lead reviewer. Now, not only LEED, but our friends over at Enterprise under the 2020 program have updated their program to require all projects to obtain the 60th percentile. So you can do that using this calculator. We've done it. And you can achieve additional bonus points in Enterprise Green 6, 8, and 10 for achieving these higher level percentile reductions, documenting it this way. So that's one thing to watch out for. And then for those of you using our Green Star Home certification, we have our brand new Stormwater badge that we're releasing that you can achieve on your project if you meet the 90th percentile or higher, and you can document that through that tool. So with that, I am super excited to hand it off to Corinne here, who will introduce herself. And obviously you all know the organization, but her part in the organization, and walk you through and guide you on the project. So Corinne, welcome, and please do take it away. And you are muted, just so you know.
All right, I believe I'm not muted anymore. So hello, thank you for that wonderful introduction. I'm just gonna share my screen here to get started. Here we go. Can you see the correct screen or do I need to switch it?
Yep. Oh yeah, no, it is the note screen. If you could switch it real quick.
Great. All right. So I am a physical scientist with the US EPA, and I primarily work on EPA's stormwater calculator. I'm the lead on that, and I help with the stormwater management model as well, and do research with respect to green infrastructure, and kind of starting to get into a little bit of water quality stuff, but I'm very new to this position, so I'm very excited to have this opportunity to present and kind of get started with introducing people to this tool. So briefly, I'll sort of talk about LEAD and talk about the stormwater calculator, and then I'm going to kind of just go through using the calculator so that you all can see how to use it, and that's going to be kind of my primary goal here. So as Brett was mentioning, for the LEAD credit, it's my understanding that you can obtain some of these credits by managing a percentile of rainfall events, the runoff from those events. And in some of the step-by-step guidance that I've seen, and this varies depending upon what you have going on as a site, if you're a if you're a homeowner, or if you're a commercial person, or if you're even a pollution discharge elimination site, then this will vary a little bit, but in general, you'll obtain the rainfall data for your project location, and you can do that using the stormwater calculator. We have a place where you can download that data for your site. Then you can determine the percentile that is pertaining to you, and then you'll run the calculator to determine the runoff volume to be managed on site. And then afterwards, you can sort of incorporate the design strategies that you've looked at in this stormwater calculator. And then eventually you have to go back and sort of confirm that everything's working the way that it should be. And that's really the extent to my knowledge about the LEAD stuff, but I will try to connect the stormwater calculator back so that so this presentation is useful for the people here. EPA's stormwater calculator is in general, it's just a planning level tool that will estimate changes in stormwater runoff given the site characteristics, and low impact development and green infrastructure practices. So it's sourcing national data sets like the Surgo soil data sets and climate data, et cetera, and it uses EPA's stormwater management model, or SWIM, as its hydrologic model. There are a few updates that we've made recently. So one is the cost module has recently been updated to more recent data. And then additionally, we've updated some climate data, which if you're curious about looking about planning into the future a little bit, this might be helpful. So the different components are the location, the soil type, that takes into account topography, precipitation, and temperature, as well as evaporation, climate. So this is, I mean, climate, I'm sort of talking about going into the future again, and then land cover. And also, most importantly here, and what we'll be talking about mostly today, is the low impact development controls. So maybe you're familiar with some of these concepts, but in general, they are going to be helping to retain rainfall on site so that it mimics natural site hydrology. And some examples of these are disconnection. So you can disconnect your gutters, you can harvest rain from your roof with like cisterns, or if you're a homeowner, like a rain barrel. You can do green roofs, street planters, infiltration basins, rain gardens. So these are the ones that we have in the stormwater calculator. And so it's pretty thorough. In general, the way that it's working is that it's going to be addressing surface runoff, infiltration, groundwater, snowmelt, stormwater detention, and it uses full dynamic wave flow routing, which that's very fancy terms for saying that it's physically modeling things very well. And this is useful, I think, in some of the documentation that I saw, and I'm not a lead person, so I don't have access to all of it, but some of the documentation I saw, there for the NPDES sites, at least, you need to at least account for, this is accounting for everything that you need to. So yeah, so it will account for runoff, infiltration, and then the green infrastructure or low impact development controls. So this is sort of a little diagram, and this, you can find this in the user manual for the web application, and also many other details about the modeling and also how to use the calculator. So it's sort of showing that this is a on-site model that that does model all of these different processes. So it's very great. So I'm just kind of going to get into how would you use this calculator potentially for your own needs. And I'm going to sort of start out from the perspective of someone who doesn't know what type of development they have. So it might be applicable to everyone. But essentially, you're going to start out with running a baseline scenario. And after that baseline scenario, you're going to use the precipitation data that you've obtained from the stormwater calculator, or you could use a different source to determine the rainfall percentile. And then you can actually design some of the low impact development controls with that design storm, that 24-hour design storm. So that means the rainfall that's occurring over one day. And then afterwards, you can rerun the stormwater calculator with a redevelopment or a new development scenario that suits your needs. And so you'll sort of just change the bottom tabs. You'll see as we walk through this, it'll make a little bit more sense. And then, you might use, if you're a certain type of person who is doing a certain type of development, you might use this lead calculator sheet that they have on their website. Otherwise, there are other, forms that you may have to fill out. I'm not going to talk about those, but I will try to provide some input into, how the outputs of the stormwater calculator may be useful to those things. So we'll start with the baseline scenario. I'm going to kind of walk through in a PowerPoint very quickly, and then I'm going to just go to the website and show. So basically, you get started by finding your site and naming your site. Very simple. You can draw a polygon around your site. And you might want to try to simulate the natural site hydrology as your baseline scenario. So, pre-development conditions. You'll enter your soil type, which sometimes the Sergo database is not available, but most of the time it is. But you can sort of zoom in and out and see what kind of the most common soil types are in your region. Sometimes the soil survey is more comprehensive for particular areas than others. So you can fill out this information. You can enter in the site topography. So is it flat, moderately flat, etc. You can look at bird's eye view, potentially, if you're not familiar with the site, you kind of just want to check it out, or you're just kind of thinking to yourself, oh, how flat is that? You can look at the terrain, so you can change the view that you have. You can then select weather stations and obtain your precipitation data and download that data and save it for later. It is a .dat file, so you will have to resave it as a text file. For this, for your lead stuff, I think that you can select no change for the climate change stuff unless you want to sort of explore and play around with this functionality. And then afterwards, you'll describe the land cover on your site, and you can adjust this for percentages to add up to 100%. And then you could describe baseline LID controls or not. I would think my intuition tells me that you would probably want to just define more of like a baseline scenario without LID controls. But it depends on what your circumstances are. There's a cost module that you'll skip if you are just sort of running this baseline scenario. If you already have a setup for things, then you might just want to skip that. And then lastly, you will run the results, and LEED recommends that you analyze 30 years. And examples that I'll be doing online, I'm just going to do 2 years because it runs faster. So you do have to be patient. If you run 30 years, it will take a couple minutes for it to load. All right, so, then you'll obtain your rainfall data, and you can obtain the percentile storm using, you can, load the rainfall data as a text file into your Excel document and obtain the percentile using the percentile function. So here's just sort of showing you that you can take this .dat file, resave it as a text file, and then you can load that into, in this way, into Excel. So you can open a document. It could be this V4 rainfall events calculator. It could just be a random Excel document, just wherever you want to keep this information. And you can open a tab at the bottom and import the data from the text CSV. There's an option to do that in Excel. And then you can then create a new column that's the date, and then you'll kind of bring some of these columns together that will amount to the date. So you'll just do at column 2, at column 3, at column 4 for the date. So then now you have this nice date column, other than, it's a little bit different. And And then after that, you can use the percentile function. So you use percentile, and you can then define whether it's, 95th, 98th, 85th, or whatever percentile you're looking at. So then you now have that percentile available to you. So you can go back and you can go back and change, land cover. If it's a new development, you may need to change some of the land cover. You can then just redefine your LID controls, and I'll show you that if you click on any of these, you'll be able to size for the design storm. So there's an option here where you can just size for your design storm. So for my particular location, I did the percentile thing, and I think the 98th percentile event was 0.43 inches. So yes, and so here's an example of, if you click on street planters, then you can adjust some of these features in here. So it can kind of be a useful tool for design in some respect. And then lastly, you can select the cost module. You can choose your site suitability. If your site is, in a mountain in the middle of nowhere, you might select that it's poor site suitability. If it's a very flat, beautiful pavement that's super accessible, you would say it's excellent. And you can choose the cost region that you're interested in. And then you can then go to the results. It will give you a warning saying, oh no, things have changed. And so you'll refresh your results for your 30 years, and then you can sort of compare those different scenarios. And it'll give you average annual runoff in inches. And there are also many other reports that you can obtain from this that will be more useful potentially than this very basic summary. So lastly, you'll take this information and you will do with it what you may to help you with LEED. And one of those things might be to adjust the controls in the stormwater calculator to compare to your baseline scenario. So you may be interested in just sort of seeing like what recipe of LID controls may be helpful to reducing your runoff. It's not going to attribute a specific amount of runoff reduction to each LID feature. So you would have to obtain that information, you'd have to rerun it with sort of just adding each LID feature individually and then comparing it back to baseline. A good way to sort of compare the LID control scenario to the baseline scenario is to use one of the report outs, where it's going to give you the % of time retained. And so you can see for this baseline scenario, which I tried to do like a mimic of natural site hydrology. So I think I was like, it's like mostly forest and grassland and things like that. And so here I'm trying to see where I want, for my design storm 0.43, I want the rainfall to be retained as much as it would for site hydrology. So you can kind of play around with your LID controls in order to sort of get to that result. So then, yeah, there's just a few things that I noticed from LEED that are just to note, and that is, so this, that it, for non-NPDES sites, and this is really not my expertise, the LEED certification stuff is not my wheelhouse, so someone else will definitely need to, talk to someone else who's more expert, but for non-NPDES sites, it seems to me that all impervious surfaces will generate 100% runoff, and the pervious surfaces will generate 0% runoff. Now that's not how the stormwater calculator will be modeling things. It will be using different coefficients, runoff coefficients, or like a percent of runoff that's associated with different types of surfaces. So brick may have like 0.8 as its runoff coefficient, where, maybe a shrubbed area might have 0.3 or 0.2, not really sure on the numbers, but just so you know that it's going to be calculating things differently than for that type of scenario. For NPDES sites, the runoff coefficients are apparently needed, and so the SWC may be suitable to confirming the total runoff, and potentially suitable for calculating the runoff retained. So that's pretty much it. And I'll come back to the summary, but now I'm going to just, since I've kind of just, really flew through that, and y'all are probably very confused, we're going to just go to the site, and now it's going to all kind of come together. And I think I have to reshare my screen, so let me do that. All right. Actually, let me just start from the very first page here. So this is the landing page of the stormwater calculator. If you Google EPA's National Stormwater Calculator, you see a big blue button that will bring you to this application. So we can name our site here Green Home, and we can get started. So it'll bring you to a map of the United States, and you'll be able to see that they always have directions on each of the tabs that are available here. And if you want to close those directions, you can just click this button. Now you can use this locator arrow to directly bring you to the location that that is sort of like I guess the automatic location, which is somewhere in Nebraska. Alternatively, you can put in an address or a zip code. So I'm going to put in a zip code here, and this is going to bring me to a place kind of near my house, but I just wanted to show you kind of a little fun example. There's a new business opening up near my home, and they were curious about using the stormwater calculator, so I figure I would test it out here. So this is the location of the business here, and I can zoom in, and if I click here, it'll reorient me to this being my location. And so now all of the data is going to be sourced within a radius of this point here. I can define a polygon around my site. So the owner, you have to be careful not to accidentally hit the street because it will bring you a street view. The owner actually owns this whole area of property here, and I'm being a little bit imprecise, but you can click and form your polygon, and it will estimate the number of acres for your site. So you can zoom in and maybe be a little bit more precise with this, but we can then go to soil type, and it's going to be trying to fetch data from the Surgo data soil database. Sometimes that database is not available, so you'll have to, you can either wait to use it another day. So today it's not available, but you can either wait to use it another day, or you could potentially try to find data from another site. I actually know generally the soil qualities around this, around my area here, and it's very clay and loamy. So I will select clay loam and move on. It's going to try to fetch the soil data again, and it won't be able to. And this is not like a common occurrence, but it happens occasionally, and I find actually for some reason around this time of day. So maybe around noon might not be available. So here it's going to ask, how fast does rainwater infiltrate pervious areas of your site? So you can kind of go back and reference your clay loam, sandy, etc. I think that this is probably pretty modest for my site. So I'm gonna say that it's about 0.1 here. And then I can move on to topography. That said, for this site, it's mostly concrete, so it may not even matter that much. So for the topography, again, it will try to reference the Surgo soils data. I know that this area is very flat, so I will just put flat. And now I will go to precipitation. So this is my site where the little marker is, and it's saying that this highlighted rain gauge station is the nearest rain gauge station to me. So I can just leave that. If I felt like it, I could select another. You can also potentially, go back, you can select one and you can download the precipitation data. If you're feeling very fancy and you have the, technical wherewithal, you could do an interpolation between different sites to obtain some rainfall data for your design storm that you're looking at. But we're just going to do this. You can download the precipitation data. If you're interested, you could also download the temperature data. And here it provides details on it. So precipitation is collected starting 1990 on January 1st. And it's ending 2019, December 31st. And it's saying that the average over that time period is about 39.67 inches. And yeah. Oh, yeah, there we go. Once again, you can see more details here. All right. So again, for the climate change stuff, you can read about it, you can learn about it, you can enjoy it if you like. We're going to skip it for now. And if there are questions about it later, we can talk about it. But I think that the future stuff in this, the future of these tabs are going to be more important to you. So here you can see some directions on describing the land cover. And you can see that if you click on the links, it will provide some pretty pictures that are more descriptive for the types of land cover that you're describing. There's also always a help button, and this will help you to understand better. So this is going to just be useful for you, but here we're going to sort of zoom in to our project, and here we can see that mostly there's maybe a little bit of lawn, but it's maybe probably less than a quarter of the property. So we'll say like 15%. And then the rest is pretty much roofs and pavement. So I will just probably leave it as 85% impervious and 15% lawn. And then we move on to the LID controls. For now, for our baseline scenario, I'm just going to leave this as is. And so the project costs are going to be associated with the LID controls, so we don't need to worry about that either. So we'll go straight to results. And again, you would want to select 30 years to analyze, but for our purposes, we're going to select 2, so it will run nice and quick. And this event threshold is important for you. So it's already set to 0.1. And that's because 0.1 inches of rain will probably just be retained on site automatically, or like not really, it's not going to be sort of like a detectable event. So that actually figures into the lead calculations from what I read. So you can leave it at 0.1 for your purposes. And then we will do refresh results, and it will generate our results. You can see even for just 2 years, it takes a couple minutes, maybe a couple of seconds. I'm very impatient. So and so here we can see that our average annual runoff for this site, which there's quite a lot of runoff, is 41.25 inches. There are other reports that you can generate. So you can look at the daily rainfall in inches and the daily runoff in inches, the rainfall runoff exceedance. So you can see the depth in inches and the days per year that the rainfall or runoff is exceeded for that depth. you can look at the rainfall retention frequency. So here you can see that it's very infrequently retained, especially for for larger storm events. All right, so we have runoff contribution by rainfall percentile. So this could just be interesting for you to look at. It's not quite as evident. It's not like a linear thing, so that's kind of interesting. And then you can also look at the extreme rainfall runoff and extreme event peak rainfall and runoff. So this is the return period over years and the depth in inches, and you can see that for the rainfall and the runoff. So now we're gonna go back to just here. Oh, and you can also see the site description. So you can see all of all the things that you input basically. And then we're gonna just use this as our baseline scenario. So now you'll see that there are 2 columns here with the same information. So now we're gonna go back and we're gonna add some LID controls. So you can see for the LID controls, there's this help button. So this provides some information, and then there are some directions here, and there's even some links to useful handbooks that people have provided. And then if you click on each one of these, it will provide more information for you and more links. So let's say we're going to do, maybe this building could disconnect. So we'll say this building is maybe 25% of the property. So of the impervious surfaces, sorry. So this is going to be, each of the percentages are going to just be the percent of the impervious surfaces that are being treated. So we're going to say we're treating 25% of our impervious surfaces with disconnection so that it can go here. Maybe this house is included in that. And then we can say, let's say we want to do some rain harvesting on the other 2 roofs. So we'll say maybe another 25% there. Oop. And let's go ahead and design some of these for, we'll set this design storm here. And so we can actually go back to the rain harvesting here, and we can see if you click size for design storm, it's now gone down to, we need 3, per 1,000 square feet, we need 300-gallon cisterns that release 50 gallons a day. You can change this. You can change all these things. I must admit that, since I've come into this role, I've noticed there are some locations on the site that I would like to improve. So for example, if I click for design, size for design storm, it only really changes the number per 1,000 square feet that you need here. It doesn't change the cistern size or allow for you to fix one or the other. So that might be something that I might be trying to improve in the future, but we'll see where I get with it. Anyway, so we'll just go back to size for design storm. Oh, maybe we want to do 100 gallons though. So we have that. And disconnection, there's no option to size for design storm because you're not necessarily going to, it's just a binary disconnect or not. But however, you might be more realistic about how the runoff infiltrates into the soil before leaving the site, and how much that might actually, end up somewhere back in the sewer system, for example. So, maybe you're near a street or something. So maybe let's say like there's a 95% capture ratio here. So we'll just be more honest about that. All right, so let's move on. We've sized all this up. We can then go to this and we can say that it's a redevelopment because it's on a property that's already existing. We're not really changing it too much. We're going to say that it's very suitable, and can move this around, and you can see there's a regional multiplier that will sort of adjust the cost. And then now it's giving us this warning that our site data has changed. So we will now refresh our results. And so now we can see before we had our average annual runoff in inches as 41.25, and we've now reduced it to 28.71. You can see nice little pie charts that demonstrate that a little bit better. And what we'll do is we'll just go straight to the rainfall retention frequency. And so you'll see that here, we're still not meeting that rainfall retention frequency that would likely correspond with what you would need for your LEED certification for the 0.43 rain event. Oh wait, never mind, we are totally doing it. So this is the current scenario. Sorry, purple is the baseline scenario. So we've significantly improved. We've actually exceeded what we need. So I think, well, TBD. You might have to ask some people, some other folks about that. I'm just going to focus on how to use the calculator, but you can look at this plot to see how this compares with your baseline scenario. My intuition is that the baseline scenario that the LEED is probably more interested in is a baseline scenario of natural site hydrology, where you're more so concerned about like the natural land cover that was there, like in the pre-development conditions, but someone else might have to confirm that. Either way, you can also look at the cost summary for making these improvements, and you can see that it gives a sort of a confidence interval around the cost to do these things. So disconnection, not sure why disconnection would be so costly. Rainwater harvesting, this also seems a bit high to me, but I've only installed a rain barrel at my house, so well, you know, there are some things that you may want to just verify. This is very much a screening tool for you, and either way, for LEED certification and otherwise, you will have to go back, I think, and verify that all the things that you install do satisfy the or do comply with your LEED credits and the different scenarios that may be important to you if you're a homeowner versus a developer, et cetera, et cetera. So this is pretty much just a very overall summary of what this is. And I'd also just want to share one last thing, which is that you could save your project. So if you have this comparison here, you can email it to yourself. So you can email it to yourself and it will send you a file where you'll then be able to go back and open that file. So the last little bit is that if you ever need help, you can click contact and you will be able to contact me for technical support. There are a few other people who sometimes back me up, but overall it's just me. There are also a list of different resources that might be useful for you in trying to make informed decisions. And just in terms of using the web app, you can always go to the documentation here, which is very in-depth, much more in-depth than I could provide in this small time. So that's all that I have. And I just wanted to thank Brett for inviting me into the LEED world. And if you have any questions, I guess now would be the time.
There we go. Thank you, Corinne. And there are some questions coming in. Before we get to those questions, just real quick, I do appreciate you bringing up that stormwater calculator from LEED. So there is a V4 one, and of course there's a V4.11 as well. So here's just an example and a link to the 4.1. Obviously, everyone, we're trying to push into 4.1 where you're allowed to do 4.1. And you'll just see some more information on that. And there's a difference, of course, on how you calculate it for new construction, which is D and C there, and then also operation and maintenance existing buildings, a little bit different there. And yeah, those questions are rolling in, but before we get to them, as a reminder, yes, you can rewatch this session, share it with your friends, colleague, post it on social media, tag us, go to Green Home Institute on our YouTube channel, hit subscribe, you'll get instant update as soon as the event is ready. for you to check it out there. For those of you watching this in the future, not right now, on demand, head over to our Thinkific channel or USGBC channel, take your quiz with an 80% passing rate, and you will receive your certificate. For those of you watching this live right now and you've been here the whole time and appropriately logged in, check your spam at certs@gutenbergcerts.com and you will receive your certificate for attendance in the next couple of days. And always, before we get to those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our top tier sponsors, Mitsubishi, Ream, April Air, all of our sponsors who allow us to do what we do and help you build LEED and beyond as well. So yeah, Corinne, there are some a very specific question came in, and I want to make sure I got it. You might have to go back. This was a little while ago, just a clarification, and maybe it was clarified, maybe not. But the question was, where did it go? It wasn't in Q&A, so I have to dig for it. So they said, okay. So there was a question about whether this is appropriate for home builders. You had mentioned developers, you had mentioned homeowners, but of course, I assume people doing new construction, just building a home, of course, can use this to make informed decisions too, right?
Yes. So I think that the cost estimates are going to be very inflated if you're a homeowner. I think that it's a lot cheaper as a homeowner to do some of these things than it would be for some of the other things. So like if you go to the National Stormwater Calculator user guide, the app user guide, you can look at what the cost summary is actually doing. And that's estimates of the actual construction costs. So that means you're not installing it yourself, first of all, and the annual maintenance costs. So that means that you are doing some compliance with maybe something, and there are some annual maintenance that you have to do in order to keep up with that. So let's just say that's just sort of one example. Otherwise, I would say it's a very great screening tool for homeowners. One challenge that I see with it for some homeowners is that like the biggest complaint that I have is that there are people whose neighbors are providing the runoff onto their property. And well, there's just not much you can do about that. So this is not going to be able to supply you with the amount of runoff that your neighbor is putting onto your property. So that's one thing that does come up, but it is a really great tool for being able to look at how having a rain garden or how collecting roof water will affect the runoff on your property.
So you had mentioned cost just a second ago, and how this might be too expensive for a homeowner or something like that. But let's get into cost for a second, because I guess I'm curious. Well, first of all, on the cost side, has this been, the stormwater calculator has been out for a while. And of course, since then, we've had hyperinflation. And so has this been adjusted? Is it adjusted for inflation? Are you surveying builders out there and their costs? And then on that, is it factored in perhaps the costs you don't have to pay if a city is either fining you or giving you incentives, perhaps, when you do these things?
So to answer your first question, the cost module was updated in 2022. So that is current.
Okay.
Things are crazy though now, so I understand that. What I was saying about the cost for homeowners was more so that because this is introducing the cost of actually constructing the low impact development features, that might be more expensive. They might provide more expensive estimates than what you could do yourself, because
it'd just be inaccurate if you're going out and doing
exactly.
Okay.
And so it would just seem very expensive when it's actually not to do it on your own home. So I personally would ignore the cost module if you're a homeowner. I would think it's very valuable though if you're like a larger building or set of buildings, for example. So and I did see this one question by Joy saying that just while we're on this topic, that I use the Detroit region, the cost estimate. There are only a few regions that we have for the cost estimator portion. And just so you're clear, it's just estimates from the Bureau of Labor and statistics. But and those are just going to be for construction and maintenance costs. So the actual materials and the construction and the maintenance, but not the distance to the site or anything like that. So
sure. Now, how do incentives come into play in this calculation? Can you say, oh, my city's going to fine me if I don't hit a certain thing, or they're going to reward me? Does that factor in, or are you able to do that?
No, but that's something that you could probably account for on your own. This is each city and each municipality will probably have its own rules, and so as a national stormwater calculator, it's nice to keep it as simple as possible for as many users as possible. And so we do not include that information, but if there's a link to that type of information for for all of the United States, that we could include that as one of our resources on this site.
So another question, and I had this question too, like where, so that, and I've seen these reports, they've come in from our teams, right? And they're pretty big, and I'm just trying to find that percentile number, right? Like, show me the percentile. We also sometimes need to determine if it's calculating at a 2-hour 24 or a 2 24-hour event. I believe I can get the exact language. So we're looking for those two things when we're scouring these reports. Where do you find those things? If you want to share your screen too.
Oh yeah. So let's see. Okay. So for the these are the only reports that are available through this calculator. And what you can see is there are different locations where you can see the daily rainfall. So if it's a 2-inch over 20-hour rainfall, then you would look here and you would be able to see the daily runoff in inches associated with that. So that's going to be between, I guess, this is for each of the scenario. Yeah. So 1.97 for the baseline and 1.85 for the new scenario. The current
now 24 hours is the other key, and I'm not seeing time here. What am I missing?
So this is all going to be 24 hours. Daily is 24 hours.
Okay.
Yeah, daily.
Got it. It's daily. I should have.
Yes.
There it is.
You just got to make that little connection, and you're good.
Okay, so that's one. And then where do we see the percentile? Where is that at?
So for the percentile, again, that's something that you have to calculate yourself for LEED. So
so this doesn't tell you the percentile. I've seen the reports and I thought I saw a percentile. So
you can download so if you go to do that. Let me see if there is a percentile here.
Oh, so it's percentile at date.
Okay, here's daily rainfall percentile. So here you can see the daily rainfall percentile, or the daily rainfall depth that corresponds to. So here I can see that my 95th percentile corresponds to 1.62 in depth, for example. Okay. And so here I can see the percent of total runoff for each of those scenarios.
And I think it was that last one you were on where we were looking for the actual day, and you know what I mean? So it's at 2 inches. That's the percentile. Is that what I'm seeing?
Sorry, say that one more time.
Well, okay, let me take a step back here. Let's say someone's like, we need to show what percentile this is to report it. It's got to be 60th, whatever. Where, so this looks like it's based on 10, 20, 30. So where would I just see like that number kind of cut and dry?
What?
Like if I just was trying to look for 60th percentile, where would I see that at?
So here's the 60th percentile rainfall event.
Okay, but typically it's at, so is that saying this report is 60th? I guess, typically we're just looking for a number. it's just either 60, it's either 95, like what is it, like what's the average for the site?
Right. So this is saying that the daily rainfall and depths
Uh-huh.
for the 60th percentile event is
Uh-huh.
0.45 inches.
Okay. Huh. So then we would also have to know the inches we were seeking.
I'm a little bit confused.
Yeah.
about your
And this is
question.
what, and maybe others, hopefully it's making sense to them and what we've struggled with. Because it's so the question here that just came in, can this tool be calculated for the 2020 Enterprise Green Site Mandatory? And yes, it can. We have reported it, but and so this question that came in is exactly what I'm asking. Like that tool is looking for 60th, 70th, 85, 95. So we're just kind of combing through all these reports, and we just need to know, what is the number, like what's the end number is what we're looking for. So
What is the end number that you're looking for?
let's just say it's 60th. Like, how do I know that this site is at 60th?
So that's the 60th
percentile
rainfall.
Yeah.
Well, from what I've understood, the percentile rainfall is used to calculate the how much water you're trying to like retain for that event. So for your 60th percentile event here, your goal would be to retain 0.45, well, not because that's not even the runoff. So it would be to retain the 7.4% of the total runoff.
Okay, so we're trying to figure out on the side going up, percentile of total runoff. We're trying to figure out what the goal is. Is it 5, 10, 15? And then from there we can say that's where the 60th comes in, or the 98th.
Right. And I think, again, the easiest way to do that, I'm not really aware of a place in here where you can easily do that, but you can download the precipitation data.
Yeah.
And then automatically use the, percentile function in Excel to determine that percentile exactly.
Okay.
Because this is just going to provide, rounded to the 10th, the 10th percentile. It's not going to provide the 98th percentile. So where was that?
Well, it's got 99, but yeah. So someone asked a great question on this. They're saying the green bar is higher than all the purple bars. Does that mean it meets all the percentiles?
I don't think for this scenario that it
Except
so by meets
okay.
the percentiles. Again, that's going to really vary from site to site. So if you're not an NPDES person, then all impervious surfaces are going to produce 100% runoff, and all pervious surfaces will produce 0% runoff.
Sure.
The stormwater calculator doesn't calculate things in that way. And so it's going to be a lot more conservative in terms of, what it's calculating. So if you're like a smaller entity, you're not like an NPDES site, then you might have better luck obtaining those lead credits. And this is, again, I'm not an expert on this, but I was looking at your documentation, but you might have better luck obtaining those credits by looking directly at so you can look at the summary results. You can look at the
that's what I usually look at, because it's
average annual runoff in inches.
That's it.
Yeah. So you can look at the average annual runoff in inches, or you can look at your percentile event that you've calculated before. And you can also find this average annual runoff in inches if you look at, so here's the, if your percentile event is 1.2 or something, then for your baseline, then your daily runoff is going to be 1.08 inches, right? So you take that 1.08 inches, and then you will have to use a little formula that they provide in your documentation and lead, with 3 components to basically determine, how many pervious surfaces do you have, So,
Mhm.
and how many impervious surfaces do you have, right? And so you can do that. So, but I think where this calculator is really beneficial is here, where you can try to match up, you
Mhm.
know, for this, if you had like let me show my slideshow again, because I had a different kind of scenario there. So in this scenario here, in the baseline scenario, I tried to simulate natural site hydrology.
Mhm.
And here I'm able to show that the daily rainfall in inches. So if it was, for your 60th percentile, it was like 0.45 right
Mhm.
here. Well, we're
Oh, sorry, it's not sharing, just so you know. It's
okay.
yeah. I'm like I don't see it. There it is.
Okay, let me just switch up here. So again, so here for the baseline scenario, I was trying to simulate natural site hydrology.
Right.
And so here you have the scenario where, this is like one LID scenario that you may have, that you're testing out, or maybe this is without any
Okay.
LID controls.
Yeah.
And here maybe is another one where you have put LID controls, and you can
Right.
see that the daily rainfall in inches is located on this x-axis.
Yeah.
You can see what corresponds to that percentile. So for your 60th percentile event, right, I think that
Yep.
was 0.45 inches. So I can look at like 0.45 inches, and I can see that I'm retaining as much as the natural site hydrology would, right?
Yeah. Yeah.
And in this scenario, I'm really not at all. So here I would try to,
Mhm.
if I had this scenario, I'd be like, okay, let's try to add some LID controls. This might actually even be, you could probably even do a little bit less if you were only trying to obtain that 60th percentile.
Mhm.
So here I think if you go to 1.2%, which is the 98th percentile, there you might need to do a little bit more. So
Yeah.
this is kind of where this becomes a useful tool, I think, is trying to figure out what combination of low impact development controls could be useful. And then
Mhm.
also just calculating the, average rainfall and average runoff. And then again, from those other plots, you can determine,
Mhm.
where, what percentile you have. So long as it's not the 98th percentile, you can find like the 95th percentile, you can find the 60th percentile, the 85th percentile. So you can find what those rainfall events would be over that 30-year period that you're looking at.
Right. And so one of our guests, he's a rater, made a good point about, when to implement this and whether you could use it during a design meeting. And it seems like if you had a design meeting, perhaps I'd imagine with the site engineer, right? Your outdoor, your engineer, your landscape architect sitting there, you could probably sit down, pull this open, and kind of start going through design, right? And trying to hit that in the construct or in the early design stage. Correct? Have you seen that happen?
I haven't seen it happen. That
Yeah.
sounds like that sounds really fun.
Yeah.
And I think actually the way I would probably do it is I would also bring up a number of the resources that are available on this website and
Yeah.
other locations, so that people could reference those as well. So
Mhm. Yeah.
that sounds like it would be a really useful way to use this tool.
Yeah. And I was really intrigued by future planning and some of the extreme, what we have been finding is that, of course, floods no longer obey their federal regulations for whatever reason. They're just non-compliant these days, sadly. I look at, what just happened in, I think it was Fort Lauderdale, Florida, sadly. Obviously, this isn't a flood prediction tool. There's lots of great tools for that, but I assume someone might want to look ahead and really think through like how much water they're really going to have to manage in certain areas in the future. So is that what that is set up to do, to sort of using some of these climate change forecasts?
It is doing it in a very rudimentary way. So it kind of
Mhm.
just groups things together by whether your area could be warmer or, what is it? Let me just kind of, I think it's like warmer. I should know it a little bit better by now, but
Mhm.
let's see. And all of this documentation is in the user manual. But yeah, whether it's
Mhm.
hotter and drier, warmer and wetter, whether it's stormy or less stormy. And so it does provide that information based off of a one of the global climate models, which is the CMIP5. And so that it is legitimate, very, very legitimate predictions coming for future precipitation data. And so that's kind of what it's doing, is it's sort of just showing you how things might change over in the future and under these different like hot, dry, warm, wet, or more central scenarios. And so you could use those to try to help yourself figure out, how you might need to change your things so that you can maybe have better luck ensuring your compliance in the future with the current investments that you're making.
And the past, there was a great question here about restoring the site back to its natural hydraulic flows. Is there does it dig back into the past and kind of tell you what the site might have been if you wanted to bring the past back?
It does not.
Okay.
But if you're a developer, right, then from the get-go.
Right.
I can, I know from looking around, I know where I live, and if I look around, I know that, you're probably, outside my window, it probably was like forested or, meadowy. So you can put those things in, and those have similar runoff coefficients. So, whether you have lawn or forest or meadow, that'll probably be very similar for runoff.
Okay.
There's still some differences, but not huge ones.
What I really liked was the rainwater harvesting you showed, and how that really connects with the water conservation piece, or even people who want to achieve net zero water, they might need to be using rainwater harvesting instead of pulling out of the ground or from the city. I'm curious, though, people obviously struggle with trying to size their rainwater, not just for stormwater, which is one thing, but sizing it to make sure it's accurate for having the appropriate amount of water they need for drinking and everything else. How could this tool be? It sounds like you wanted to make some updates, but would it ever be useful to help size water that you actually want to try to guess how much?
It might provide some hints at what you might want to do, but there's documentation available if you go into the LID controls tab, and then you do click on that tab. So the rain harvesting tab, and it brings you to, if you click learn more, the Cable Brandel Center, it provides you the Virginia Rainwater Harvesting Manual. That's from 2007, but it's very extensive, and it provides anything from it provides information anywhere from basically different types of systems, residential, commercial, industrial, agricultural, or fire suppression. And then it goes into, it does have a tab for lead certification. It talks about the different components: plumbing, tanks, conveyance, filters, and cleaning and maintenance. And then it also will talk about treating for potable water. So you can look there, and it'll provide, there's a lot of documentation within the calculator that you can find, and a lot of information you can find here that could be useful to you. Okay, great. And one picture you had showed well, if someone has gutters, we're just in this line of work, we're happy. Like step one, have gutters. Step two, divert gutters to appropriate place. You showed a picture of a gutter kind of just going somewhere. And I want to make sure I clarify what you said, that does not get counted in the calculation then? If it's just a detached gutter that's just sort of dumping into the ground there? So it is accounting for disconnection. So what I mean by disconnection is if the gutter is going straight into the sewer, if you're like on a combined sewer system, then, that's going to be, one scenario where you're removing that from your property. But if it's detached, then it's going to be infrastructure. It depends on what kind of like sewer system you have going on. Right, because if it's just going straight into the storm, you're not preventing anything, right? You're just causing problems. So you're stopping the site flooding, so not damaging your property, which is a good thing. Right. Okay, so it's just depending on that situation. But I assume it's different if it's dropping into something permeable versus impermeable, correct? Yeah. So Yeah, so my neighbor's gutter goes right into our driveway,
Mhm,
which is great for our driveway.
mhm.
And then and I'm being very sarcastic about that. Our gutter, we have it going into a small bioswale that we've
Mhm.
constructed next to our house, with
Yeah.
some shrubs that are, they're, you know, chosen for their capacity to absorb water. So
Okay.
that's obviously, we're going to have better luck with
Mm.
managing some of our runoff, using that approach than if we were to like shove it onto our neighbor's driveway.
Right, right, right. And just quick on the last question, kind of going back to the future, the question was about, using artificial intelligence to extrapolate rainfall conditions based on human action. So the assumption that cities are getting bigger, urban sprawl, those kinds of things. Since this is site-based, I'm not sure, but any thoughts on that?
So, um, so the I'm not a global climate modeler.
Yeah.
But I imagine that some similar approaches are being taken and being accounted for in
Mhm,
things like the CMIP5,
mhm.
and other global climate models. So there's that.
Okay.
Um, I wish I could see that comment. Where did it go? Oh, here we go. So, yeah, okay. Yeah, and so I think so. The one thing that you should know about this particular calculator, Imani, is that it's an on-site approach. So it's using swim for just an on-site location. If you wanted to do something where you're looking at how things are flowing
Mm,
across places to other places, then you would need to contact
mm,
a professional who can use something like the stormwater management model, to develop a model to do that. And SWIM is one of EPA's applications. It's also just a bunch of code too. And we are actually looking at there are examples of research that people have been doing where they have been trying to extrapolate those rainfall
mm,
conditions. And so that's an interest and a curiosity that we have, and trying to see how we might integrate
mm,
some of that information better into something like the stormwater calculator
mm,
is definitely a question
mm,
that we are thinking about.
mhm. Well, great. Thank you so much, Corinne. We are at our time today, but I really appreciate you, appreciate the EPA for allowing you to come out and talk to us. Where can people go if they want to learn more, access the calculator, reach out to the EPA with any questions?
So for the stormwater calculator in particular, you can reach out to, it's going to be me at SWC at EPA.gov. For other questions, you can reference EPA's website if you want to look at other tools. If you do need help, looking to trying to figure out what need you have and how to fulfill it with one of EPA's tools, you can also, anyone here, feel free to reach out to me and I can try to do my best to put you in touch with whatever application or tool or person
Mm,
that may be helpful to you. We are the government, and
mm,
so we are quite siloed, and we're
mm.
trying to stop being so siloed. But I feel like I do a pretty good job at reaching out to people in different places in our organization. So just let me know.
Great. Well, thank you so much. Thank you all for attending. We'll see you all next week in May. So take care. Goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.